Hi children, we continue with our fourth chapter, carbon and its compounds, and our today's topic is some important carbon compounds. In the previous class we learned about the first important carbon compound, that is ethanol. Today's class we will learn about the second one. Ethanoic acid. Ethanoic acid, the formula is CH3COH. Again we condense it and write C2. How many hydrogens? 4. O2. Okay. C2H4O2. This is the molecular formula. So CH3COH, ethanoic acid, and its molecular formula is C2H4O2. Okay. This acid is commonly, ethanoic acid is commonly known as acetic acid. This is a commonly used acid under the name acetic acid, and we have learned it under weak acids, isn't it? So acetic acid or ethanoic acid is a weak acid. Why is it called a weak acid? It undergoes only partial ionization, and the number of H plus ion produced when it is mixed with water is very less. So it is a weak acid. So ethanoic acid is commonly known as acetic acid. Then a 5 to 8% solution of acetic acid is known as vinegar. Vinegar is a widely used food preservative. We use it in pickles and all. We make use of vinegar in pickles and certain other dishes too. So it is a food preservative, widely used food preservative. So it is a 5 to 8% solution of acetic acid. What do you mean by a 5 to 8% solution of acetic acid? So total 100 gram, that is 5 gram acetic acid plus 95 gram of water. Last year 9th standard you have learned mass by mass percentage, expressing concentration, mass by mass percentage, mass by volume percentage, etc. So 5 gram of acetic acid is mixed with 95 gram of water. So the overall will be 100 gram. In 100 gram of the solution, the weight of acetic acid is 5 gram, that is 5% solution. So 8% means 8 gram acetic acid and 92 gram of water. So the amount of acetic acid in such a solution is very less, only 5 to 8 grams of acetic acid in 100 grams of total solution. So 5 to 8% solution of acetic acid is known as vinegar, and it is widely used as a food preservative. Okay. Now the freezing point of pure ethanoic acid is 290 Kelvin. Freezing point of pure ethanoic acid is 290 Kelvin, that is 17 degrees Celsius. So it often freezes in cold climate. Some countries the temperature will be always very low. At 17 degrees Celsius it starts to freeze. That is the reason why pure ethanoic acid is known as glacial acetic acid. It is an important question. Why pure ethanoic acid is known as glacial acetic acid? Reason is it has a very low freezing point. 290 Kelvin is its freezing point. So in cold climate it starts to freeze it appears in the frozen state in cold climate. That is the reason why pure ethanoic acid is known as glacial acetic acid. It is an important question. Its freezing point is 290 Kelvin and it often freezes in cold climate. So it is known as glacial acetic acid. Now we have to see the chemical properties. Since it is an acid, it will undergo all reactions of acids. In the second chapter we have learned the chemical properties of acids. So this is a weak acid, but it is again an acid. So it will undergo all chemical reactions of acids. First one is reaction with sodium, a metal, sodium. So what happens when an acid react with a metal? Acids react with metals to form salt and hydrogen gas. So this is an acid. So salt and hydrogen gas will be produced. CH3COOH plus Na. So what do you get? CH3COONA plus H2. So this is the salt. Its name is sodium ethanate, commonly called sodium acetate. So Since ethanoic acid is an acid, it reacts with metal to form salt and hydrogen gas. Here the salt formed is sodium ethanate, CH3CO. The hydrogen is removed. This hydrogen atom, COOH, this hydrogen is removed. From the COOH group, the hydrogen is removed and that position is occupied by sodium. We call it as sodium ethoxide or commonly known as sodium acetate along with the liberation of hydrogen gas. So, that is a reaction with sodium. Metal, salt and hydrogen gas are formed. Next, a new reaction and very important reaction known as esterification reaction. Esterification reaction. Carboxylic acids, not only ethanoic acid, carboxylic acids react with alcohols to form esters. This reaction is known as esterification. Reaction between a carboxylic acid and alcohol in presence of acid catalyst. Concentrated sulfuric acid mainly used as a catalyst here. So, carboxylic acids react with alcohols in presence of acid catalyst to form ester. This reaction is known as esterification reaction. About esters we have learned in 8th standard. Polyester. Esters are sweet smelling substances which are used to make perfumes and also they are used as flavoring agents. So, reaction between a carboxylic acid and an alcohol in presence of acid catalyst to form ester, that is known as esterification reaction. These esters are sweet smelling substances which are used to make perfumes and also used as flavoring agents. So, we will see how ethanoic acid reacts with alcohol ethanol. This is ethanoic acid. We will see how it reacts with ethanol. What is the formula of ethanol? Ethanol is written as CH3, CH2, OH. So, I have written it the other way so that I can show you the reaction how these two molecules combine, CH3, CH2, OH. This is ethanol. The only difference is it is written from right to left. There is no change in the formula CH3, CH2, OH. So, when they react in presence of an acid catalyst, what happens here is one hydrogen and this OH. Hydrogen of the acid combines with OH of the alcohol and H and OH makes water. A molecule of water is removed. Now, what is left? We can write the formation of the product CH3COO. Now, H is not there, H is lost. CH2, CH3. Now, what is the other product? The water that is removed. So, this is the ester COO. This functional group is known as ester group. So, under the functional group that we have learned, we learned only alcohol, carboxylic acid, aldehyde and ketone. This is another functional group which you will learn in higher classes. So, this is the ester group COO. This is the ester. So, please understand the H of carboxylic acid group and OH of the alcohol combine, they removed as a molecule of water. Now, the remaining portion we write as CH3COO. CH2, CH3. This is the ester. Okay. Now, when this ester is, so what is this reaction called? Reaction between ethanoic acid and ethanol in presence of acid catalyst. It is known as esterification reaction. The ester formed can be used for making perfumes and also it can be used as a flavoring agent. Now, this ester that we got, CH3, COO, CH2, CH3. When it is treated with sodium hydroxide, what happens is the bond breaks here. When sodium hydroxide is added here, the bond will break. Na adds on this side, OH adds on the other side. So, what do you get? CH3, CO, ONA. This is the sodium salt of acid, sodium acetate plus CH3, CH2, the same alcohol ethanol you get back along with the sodium salt of the acid. This reaction is known as saponification reaction. Saponification reaction. So, when ester is treated with sodium hydroxide, the molecule undergo breaking here, resulting in the formation of sodium salt of the acid and alcohol. Same alcohol is obtained back. We call this reaction as saponification reaction. This is used in the manufacture of soap. This process is used in the manufacture of soap. Usually soaps are sodium or potassium salts of long chain carboxylic acid. This carboxylic acid, we have only 2 carbon atom. Long chain means the number of carbon atom will be more than 15. So, long chain CH3, CH2, CH2, like that you have to write. So, long chain carboxylic acid. Sodium salts of long chain carboxylic acids are known as soaps. So, this reaction is called saponification and this is used in the manufacture of soap. So, that is esterification, reaction between ethanoic acid and ethanol, usually carboxylic acid and alcohol in presence of acid catalyst to form ester. The equation you have to write, only if you write it several times the equation will be clear to you. That in the middle there is a bond COO, that bond is called that functional group is called the ester group. Okay, then saponification, ester is treated with sodium hydroxide. Again breaking of the molecule resulting in sodium salt of carboxylic acid and alcohol, that is saponification. Okay, now the other reactions are easy. Third reaction, reaction with bases. So, ethanoic acid is an acid. So, we will see how it reacts with bases. How do acids react with bases? Acids react with bases to form salt and water. What do you call those reactions? Neutralization reaction. So, here what will be the salt formed? CH3 COONA. You can see that all these reactions, hydrogen of the carboxylic acid group COOH, that hydrogen is the reactive hydrogen there. Okay. So, that hydrogen is replaced with a sodium atom. So, you get sodium acetate, sodium ethanate or commonly sodium acetate with water. So, this is an example of a neutralization reaction. Acid reacts with a base to form salt and water. Here acid is weak, base is strong. So, what will be the nature of the salt formed? It will be a basic salt. This we have learned in acids, bases and salt. CH3COONA. This salt as an example of a basic salt we learned in acids, bases and salt, because it is formed by the neutralization of a weak acid with a strong base. Next reaction, reaction with metal carbonates and hydrogen carbonates. Metal carbonates and metal hydrogen carbonates. So, this reaction also we have learned in the second chapter. What happens when an acid reacts with a metal carbonate or a metal hydrogen carbonate? What are the products obtained when an acid reacts with a metal carbonate or a metal hydrogen carbonate? We get salt, carbon dioxide and water. We get salt, carbon dioxide and water. So, CH3 COOH plus NaHCO3, metal hydrogen carbonate. What you get is CH3 COONA, salt, plus CO2 plus H2O. Same salt you are getting, CH3 COONA, along with the liberation of carbon dioxide and water. Now, when it reacts with metal carbonate, what you get is plus CO2 plus H2O. Same salt, same products you are getting. The change is only in the balancing part. So, when acid, ethanoic acid reacts with metal carbonate or metal hydrogen carbonate, you get salt, carbon dioxide and water. The salt obtained is sodium ethanate or commonly sodium acetate. Okay. So, that is all about acetic acid or ethanoic acid. Thank you, children.